Hello and welcome to the day 5 lecture for our Upward Bound Integrated Math 1. Today we're going to look at solving 1 and 2-step equations. And in order to accomplish that, we do need some definitions. So our first definition, an equation, is a mathematical sentence. Okay. And really nothing else can really be said about it other than, we talked about expressions before being just mathematical statements where they were kind of fragmented sentences, whereas an equation would be considered a full sentence, a complete sentence, in that something can really be determined from that equation. So the solution to an equation is the value that makes the equation true. So the value for the variable, maybe I'll put that in there, for the variable. And if there are more than one variable, the value for all those variables that makes the equation true. Okay. The way we, and not to get too far into this, but the way that we solve equations is by using inverse operations. And inverse operations are the opposite operation that is shown. Okay, and by that I mean we have addition and subtraction are inverse operations. And also multiplication and division are inverse operations. In other words, if I want to undo addition, I would subtract. If I want to undo multiplication, I divide, and vice versa. Now, in classes where I take a little bit more time on this, which I promise I'm not going to do here, I lay out what each of these properties of equality, how they're used. But basically what I want to say here is these 4 properties of equality just all kind of come together to say that I can add, subtract, multiply, or divide any number, and I'm going to kind of say maybe divide, let's say divide not 0, because I can't divide by 0, but I can add, subtract, multiply, and divide any number to both sides of an equation to preserve the validity of the equation. Meaning I can do all these to both sides of the equation and the equation does not change. Okay, so all these kind of come together to basically mean this one idea. So technically, if you were to see this somewhere, you might see like A plus C. Or let's kind of back up a little bit, and let's say if I start with in all of these, let's say I started with A equals B, so something equals something else. This could be anything like x equals 3 or 5 equals 5 or whatever the case may be. But if 2 things are equal, I can add the same number to both sides. So A plus C would equal B plus C. Same thing for subtraction. A minus C equals B minus C, and so on. Okay, multiplication and division, those all work the same. Again, the only caveat is that I cannot divide by 0. But in the first 3, that number C could be 0. So this kind of brings us to how we solve equations. To solve equations, we think about undoing what is happening to the variable in order to get the variable by itself, using these properties of equality and our inverse operations. Okay, we're going to see plenty of examples of this today. I don't want to get too involved in this little idea on how to solve equations. The main thing is I want to undo what's happening to the variable. Now, if we think of standard order of operations, we think of PEMDAS, or parentheses, exponents, multiplication, division, addition, and subtraction. Okay, we think about following that order from left to right. Now, the difference here is that when we are looking at solving, we want to flip that order of operations. Okay, we want to do it in the reverse order. Deal with our subtraction and addition first, because remember, even in order of operations, we kind of group these two and we group these two. And when we're solving equations, we want to do that same thing but backwards. We want to group those two. So deal with our subtraction and addition first, and then our multiplication and division second, and then finally anything inside, any exponents or any parentheses at the end. And we'll look at how sometimes your parentheses are there and sometimes they're just kind of implied, and how we deal with those. But it shouldn't be too bad. Let's go ahead and look at some examples. So the first thing I want to look at is some one-step equations. And really all we're doing here is, it's called a one-step equation because there's one thing happening to the variable. And we want to undo that one thing that's happening to the variable. So in this first one, I see that I have my variable x and 7 is being added to it. So I want to undo that using inverse operations. So since it's addition, I want to do subtraction. So I'll subtract 7 on both sides. And this is basically that subtraction property of equality, saying that I can do that to both sides and everything stays the same. Nothing changes. I haven't done anything outside of the rules that I can follow. So my 7s are going to cancel because 7 plus 7 is 0. Sorry, 7 minus 7 is 0. So my 7s will cancel, and I don't write plus 0. That's just a wasted step. And 16 minus 7 is going to be 9. So I get x equals 9. That's a one-step equation, and that's going to be kind of our goal. We want to, in developing this idea of solving equations, we want to slowly increase the difficulty in what we're doing to get to something that, if we see something a little bit tougher, I should say, I want to work it down to a one-step equation and then solve that like we're working on right now. So I'll get more into that as we go. So here I have 5 times x, because it's written as 5x. 5 times x equals negative 35. So the way I undo multiplication is I divide. So I'm going to divide by 5. Since I do it on one side, I have to do it to the other to not, change our equation here. So I do it to the other side. And then the reason this works out, and I'm going to talk about it now and then later on, just assume that we know that that's why we do that. 5 divided by 5 is 1. So this really turns into 1x. And then negative 35 divided by 5 is negative 7. We don't really write the 1x, we just call that x. That would be like writing, in the previous problem, x plus 0. So in the addition subtraction world, we don't write plus 0. Just like in the multiplication and division world, we don't write times 1. Okay? The reason we don't do those things is it doesn't change my value of x at all. It has no effect. When I multiply 1 times anything, I just get that anything. So in this problem, I just have x equals -7. And you don't even need this middle step right here. It was kind of a wasted step. So then for this one here, what's going on? What's happening to x? It's being subtracted by 2. So I want to undo that, or I want to do its opposite. I'll add 2 to both sides. Because I started here, I started on the x's side, and I looked at what was happening to it, I did its opposite, and then whatever I do to one side, I have to do to the other. So again, this would be like writing -2 plus 2 is 0, so x plus 0 equals -3 plus 2, which is -1. Again, I don't need to write plus 0. That's just a blank step there. That doesn't really tell me anything. And because adding 0 to x will not change it at all. So in the next row down here, we have -8 times x equals 48. Since it's -8 times x, I'll go ahead and divide by -8. Since I divided by -8 on the left, I have to do it on the right. Again, -8 divided by -8 is going to be 1, so I just have x. 48 divided by -8 is -6. And so I get an answer of x equals -6. Okay, on my next one here, I have x divided by 4 equals -5. So since I have division here, I want to multiply. So I'm going to multiply by 4 over here to make that 1x. Since I multiplied by 4 on this side, in order to make sure that this equation stays the same, I have to do that on the other side as well. And -5 times 4 is -20. Okay. So I've made it through those ones. Let's look at this one. This one's a little bit different because I have a fraction involved. I have a fraction that's being multiplied by my x. So technically I want to divide by whatever is being multiplied by x. That was our goal. That was our strategy. On this side, I'm going to write it like this. I'm going to say divided by 4/5. Because that's actually going to make my life a little bit easier. Just ever so slightly. But the long and short of it is, on this side, I have something divided by itself, which is just 1. So I get x over here, or we say more loosely that these two cancel. And then that's going to equal, well, when I'm dividing by a fraction, if we remember that, I actually take my first number and leave it alone. I'm going to write it as 8 over 1. I switch to multiplication and I flip my fraction. So 5 over 4. Okay, 8 times 5. So now I'm multiplying fractions. I multiply straight across. I'm multiplying fractions. 8 times 5 is 40. And 4 times 1 is 4. 40 over 4 is going to be 10. Now, more commonly on a problem like this, you might see, let me erase what I've done here, not to devalue that at all, but just to give a different idea of how to do this. Since when I divided fractions, I actually end up multiplying by its reciprocal, or I keep switch flip, or whatever whatever verbiage we use. You'll often see people just go straight to multiplying by the reciprocal here. And they'll say 5 over 4 times 5 over 4. It's kind of one less step. It's kind of a little bit easier. Um, and the reason this works is if I look at this side, 5 times 4 is 20, 4 times 5 is 20. I have 20 over 20, which is just 1. So I get my x. And then over here, same idea, multiply 8 by 5, I get 40. 1 by 4, I get 4. 40 over 4 is 10. Okay, so that's the idea with one-step equations, and our entire goal in any equation is to get what is the variable equal. And a common way to get there is to work towards simplifying your equation and turn it into less steps by doing a step, basically. So every equation is going to end, right before it ends, it's going to look like a one-step equation, just like some of these. So in our problems below, they're technically two-step equations because there's two things happening to the variable. Okay, and I do need to apologize for these. I'm going to try to get rid of them here. These are just, hold on. These are just these little lines right here. This is not negative 101. This is like a leftover from a, what do I want to say? A cell that kind of brought these problems over. So so it happens on those two problems right there, and those make it a little bit easier to deal with rather than negative 101 on that problem. That's not a very nice problem. All right, so getting to this, let's go ahead and look here. So I have two things happening to the variable. If I knew what the variable was, I would first divide it by 2, and then I would add 3, and I should get 19. So I'm going to undo that stuff in the opposite direction, or what I like to tell students is to start on the same side as x, and that's why you see some teachers teach you to put this line down here. That's one of the reasons. And look at the same side as x and start as far away from it as I can. That's what I think about doing, is starting as far away from it as I can. So I know that looking at farthest away, if I knew what x was, I would divide by 2, then add 3. Adding 3 is the farthest away. So I'm going to undo that by subtracting 3. The other reason teachers will go with this line idea through the equal sign is that whatever I do on one side of the line, I have to do to the other. So that's that other piece of solving equations. And then I get x over 2 is equal to 19 minus 3, which is 16. And then look at that. I have a one-step equation. Now there's only one thing happening to my x. So I had two things happening to x. I took a step, and then now there's only one thing, and it looks like one of these problems up here. Not exactly the same because the numbers are different, but that's okay. So from here, I know that 2 is being divided by x, so I'm going to multiply by 2 on both sides. And when I multiply by 2, I'll get that x equals 16 times 2, which is 32. Okay. Next problem, a little bit tricky just because it's dealing with decimals, but that's okay. We can handle that. Again, if I knew what x was, say x is 10. I don't think it is, but just pretend that it is. And I wanted to work with this left-hand side. I would divide by 2.5 and then add 3.2. So I want to undo the farthest thing away, the last thing that I would do if I knew what x was. I want to undo that first. So I'll subtract 3.2 from both sides. That's going to give me x over 2.5 is going to be equal to, that looks like about, what, 1.4? Yeah, I might need a calculator eventually. Another thing. Sorry, trying to do my work ahead of time and it's not working for me. Okay. And the next thing I want to do is, again, I have a one-step equation. X is being divided by 2.5. So I'll multiply by 2.5 to get rid of that. And again, I'm thinking about, well, yeah, that means 2.5 divided by 2.5, which is 1. 1x, I just write that as x. Okay, that's the kind of behind-the-scenes part of that. And then 1.4 times 2.5 actually turns out to be 3.5. I would totally be okay with you using calculators, especially on fraction or decimal problems. Okay? It's kind of what calculators are made for. They're kind of made for decimals. All right, next one. I have 3x plus 5 equals negative 10. Start as far away from the x as I can, but still on the same side. So I'm going to deal with the 5. Subtract 5 from both sides. 3x equals negative 15. And now it's a one-step equation where I want to divide by 3 on both sides. And x will be negative 5. Okay. Next problem here. I have 12 equals, so the only thing different on this problem is that the variable and everything is on the other side, and we're using a different letter for the variable, but that's okay. Start on the variable side as far away from the variable as I can, and I should subtract 9 first. So over there I get 3, and over here I get, oops, wow, didn't mean to do that. So over here I get 3, and over here I get n divided by 2. The way I undo dividing by 2 is I multiply by 2, and whatever I do to one side I have to do to the other. So I get 6 equals n. Now one thing, if you don't like writing it that way, it's always okay to switch everything on each side of your equal sign without changing any positives or negatives. It's always okay to do that. The next one, there's kind of a couple different ideas of how you could do this. But here's how I'm going to look at it. Because most of the time when we see parentheses, we automatically think distributive property, especially since we've already talked about how to do the distributive property. That's an okay way to do this. I'm not going to do it that way here, because I'm going to keep my same thought process. If I knew what g was, let's say again, maybe g is 10. I don't think it is. But I would add a negative 3 to it, and then I would multiply it by 10. So I'm going to start as far away again, which means I'm going to start off with dividing by 10. And when I divide by 10, this 10 over 10 is just 1, so in a sense they cancel. That's how we would write it. And I get negative 3 plus g equals, and over here, negative 30 divided by 10 is negative 3. Okay. And then what I need to do, now I have a one-step equation where negative 3 is being added to g. And usually this addition would make us think subtraction, to subtract to do the inverse operation. But technically written, this, you could rewrite this as, and we've talked about this before, as g minus 3. And maybe that's a little bit better way to write that, because that tells us what we actually need to do here is to add 3 to both sides. Notice if I were to add 3, if I were to think about, well, I need to undo what's happening to g, and so that's addition, so I need to do subtraction. If I subtract 3 on both sides, this becomes a negative 6. It doesn't become a 0. We want to make it a 0. Okay? So negative 3 plus 3 is going to be 0, or just g. And negative 3 plus 3, oh, look at that. It is 0. Okay? So I get g equals 0. Perfectly okay answer. I get a lot of students that freak out when they get 0 for an answer. They think they did something wrong. That's okay. Okay. So for the next one here, again, I want to think about that same idea. If I knew what W was, pretend W was 10, I would subtract 1, and then I would divide 7. So I'm going to start with that 7. I'm going to multiply by 7 on both sides. And that would give me W minus 1 equals 1 times 7, which is 7. And then I want to undo what's happening to W. W is being subtracted by 1, so I'll add 1 to both sides. And that'll tell me that W equals 8. So kind of that idea of the order of operations in the opposite direction doesn't really work if we think about this, because subtraction and addition would come first, but I do not want to add 1 to both sides first. That's not going to work out. The reason behind that is there's a kind of ghost set of parentheses right here. They're not shown, but you would need to put those parentheses there to do this part first if you knew what W was. And we can always check our answer by saying, well, we just said W is 8. 8 minus 1 is 7, and 7 divided by 7 is 1. So it works out. So checking your answer is something that you can do if you have time. I always encourage it on mastery challenges because you want to make sure you get those answers right. So plug them back in, see if they work. All right, so here's kind of an application type problem. It says to write and solve the equation that's described. And this is a little bit of a practice in writing equations also. When we're writing equations, the key word we're looking for is the word is. This word is going to be our equal sign. Okay? And so here it says -1 is 8 more. So 8 more. Actually, let me just read this. It says 8 more than 3 times a number. So when something is more than, that should actually come last, because this would mean that I want to go 3 times a number. So let's say 3 times a number, and then 8 more than that. But if you wrote it as 8 plus 3n, that would still be the same thing because we have commutative property here. All right, so that's writing the equation. Let's go ahead and solve it. I'm going to start by subtracting 8 on both sides. -1 minus 8 is -9. And over here the 8's cancel, or they equal 0, which is the same thing as canceling in addition and subtraction. So 3 times a number equals -9 now. And so I want to divide by 3 on both sides, and I get that n is going to be equal to -3. And again, we could go back and check. If I put -3 in for n, if I think about what is 3 times -3 plus 8, 3 times -3 is -9. -9 plus 8 is -1. And that's what we had to start. So that is solving 1- and 2-step equations. Typically, a kind of integrated 1 class would probably spend about a day on each one of these. We covered it in 1 day, so that I know it's a lot of work, but I think we can handle it. So that being said, give your homeworks a shot, and if you have any questions, feel free to ask. Have a good day. We'll see you in class.